Everyone, my name is Alicja Kucharczyk, and I work for Microsoft as Principal Program Manager in the Azure Database for PostgreSQL team. And today I'm joined by Dilip from AMD to talk about bottlenecks you might encounter when using Postgres in the cloud. And this talk is mostly aimed for those of you that are just starting the journey with Azure and Postgres, just to make you aware of some specifics and get the best from the managed service. So we'll start with Azure geographies and the word that is very commonly used in the cloud environment, which is latency. And I will show you how to recognize that your client and your database server, in here Postgres, is pretty away geographically. Then we're gonna go through the hardware and software life cycle, and we'll finish at one of the most common myths, which is like connections, which is totally counterintuitive how it works in Postgres, and this is one of our main issues when it comes like to the support cases. And just before I start, how many of you has ever heard about Postgres? Okay, nice to see. And how many of you have used Postgres in any way, like select one at least? Okay, this is good to see on mainly SQL Server / Fabric conference, so I'm really happy. Okay, so we've got this managed service, which is Azure Database for Postgres Flexible Server. I know like the name could be a bit shorter, but it is as is now. I'm not sure why this is getting like automatically, changed like the slides, but I will just go back. Okay, so Postgres, as any other service, needs to be deployed somewhere. So you as an end user needs to choose the location where your Postgres service will be deployed. And you've got a lot of options to choose from. And what I wanted to show you, it's my favorite page when it comes to the Azure regions. Let's see. Okay. Yeah. I'm on hotspot connection. Okay. So this is my favorite page because it's interactive, it's 3D, right? You can zoom in like to take a look at the specific regions. You can hover over some of the regions, for instance, like Poland Central, to see some details of the specific regions. And so this green or blue circles, I'm not sure what is the color, are the regions, right? And the lines that you see here, this is the networking infrastructure between the regions. And we are trying our best to make everything to work as fast and efficient as possible, but there are some stuff that we are not able to overcome, and one of this stuff is physics. So, if you've got like two very distinct regions, you cannot expect like your latency can be low between like those regions, right? Like this is just a physics. And just for the test, to show you what is happening on the Postgres side when you do such a thing. So for instance, place client in one region and then database on the another region, what you will see from the Postgres to just be aware that that might be your problem. So the latency might be your problem. And I've chosen two regions based on the coconut growth. So that would be South India, where I deployed my database, and the second one gonna be UK South, according to the Monty Python documentary. In the UK South, at some time there were like coconuts like plantations. So let's trust the documentary. And yeah, what I'm gonna do. Okay. On the left, you'll have like a database which is placed in the South India. And I just logged into PSQL, to my database using a PSQL client. And I'm doing like very standard thing. So I'm querying the pgstat activity view, which is a very classic view in Postgres that is showing you all the connections that are coming to your database. Because Postgres has this architecture, then each connection, each client connection, do create a separate process, and like you will have the list of all the processes that are actively running or are in the idle state on your database. And on the right, I'm using the very standard benchmarking, Postgres benchmarking tool, which is pgbench. And what I'm doing, minus C, it's how many clients I'm going to use. It's 100 clients. And minus T, it's the time for which like the test is going to run. So in this case, it's 120 seconds, so it means 2 minutes. Okay, so we'll probably... And I'm not sure if you know this cool thing. Yeah, just in the PSQL, you've got the watch statement. So for instance, if I'm doing like select star from pgstat activity, then I can type watch, and PSQL automatically will run the same query each 2 seconds. So I don't need like to sit and, just hit like enter, 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 just it will be done automatically for me. And on the right, like the pgbench test is starting. Yeah, maybe a bit like, maybe let's go to the results. Why this is not, it was working at home, so not sure why it's not working in here, but okay, let's go to the next one. So this is the most typical thing that you're gonna see when you've got client and database in the different location. So the wait event, which is client read, and the state, which is idle in transaction. And usually when you've been on-prem and you saw like the state which is idle in transaction, that was something very, very bad. But in the cloud environment, unfortunately, because of this architecture, you will see that much more often than on-prem. And then if you do like the group by, so you would like to aggregate all the wait events and all the states that you see in the pgstat activity, you will see that this client read plus idle in transaction state, this is something super characteristic for like the client and DB being really away from each other. So you will see that in the pgstat activity, there's like multiple tools that you can use like to capture like the snapshot of pgstat activity, because it's always like real time. So you need to capture the snapshots from time to time, but most of your like monitoring tool will do that. So these two, like watch out on them. That would mean like a problem with the latency. And I'm not sure why this slide's getting changed all the time, but okay. Okay, so we've got the regions. It's keep changing, like without my intervention. Okay. Okay, then you've got the AZ. Okay, maybe I will go back like by 2 slides. And now I will wait like for them to switch. Okay, you've got also AZs. So some of the regions has got the concept of availability zones. Some of the regions do not have it, but some, like especially big regions, would have like exactly 3 availability zones. And what is availability zone? As you see in here, okay, Okay, each zone has completely independent power, networking, and cooling, and each of the AZs do have at least one or more than one data centers. So within a region, you would also have these availability zones, and it's the same case as with the regions. So if you place your app and DB in the same AZ, you can expect lower latency than if you place like your DB and your app in different AZs. And you also will see a bit of that. So still client read will be like one of the wait events that you're gonna see. And you still will see like idle in transaction state, but it's gonna be not that common as before, right? So you clearly see that the main problem now is the wall write. Wall is in Postgres write ahead log, so the place where all the transactions are stored. So this is like your transaction log. So this is evidently like the problem with the disk, which was probably not fast enough to keep up with the load. And then like the latency thing goes into the second place. The same with the state, right? Like the state that you want to see on Postgres is active, right? This should be like the best scenario. It's that you see only the active connections, only the active sessions, right? That would be your perfect scenario. But you see at the second place also in the idle in transaction, but not like that much as before. Okay, and just of course, pgbench is benchmarking tool. So benchmarking tool usually do provide you with some results of the benchmark. So that was 2-minute test. You see like different regions, it was number of total transactions proceeded, it was 3,000, and same zone, it was 500,000, right? This is really huge difference, and only the latency, only this distance between the regions was the change, right? And the latency average, as you see, 1 second. It's not only like the networking latency, but also the latency when Postgres takes the connection and it's creating a new process for this connection. But as you see, this latency, it's much slower than when it comes like to geographies, right? Just 1 second comparing to 23 milliseconds. And the TPS also 2 order of magnitude difference. So watch out on that. For instance, if you are using Flex and you are using Flex with HA, right? You can set up the HA to be in different zones. Of course, this is great for reliability, right? If something will go wrong with one AZ, then you can automatically switch to another AZ. But yeah, like then your app will stay like in the old AZ and will connect to the second AZ, right? So you will start to see much more of this kind of events. Okay. Yeah, I'm not sure how many of you have seen this one, like this picture. Yeah, you did. Oh, you too. That's great. So that was my first computer that I had at home, Amiga 600. And I really love that. Like I had a lot of games. Like, yeah, I played like crazy. But the fact is that hardware do not last, right? Some of us like still remember like this this computer, but I'm not sure how many of you would like to run production workload on that today, right? And the same is in Azure, the same is in Flex. So when you're just creating flexible server, you will have a lot of options. You can choose like between two compute families, two different companies, which is Intel and AMD. My colleague is from AMD. And also, when you choose the AMD or Intel, you will have this entire list. And at the end of each name, you will see this V, right? You will see here V3, V4, and V5 on this screenshot. And this V means generation of the compute. And the same as with Amiga and other, another hardware, you should always choose like the highest number that you see in there. Okay, so in this case, that would be V5, which is the newest one. And price would not be your excuse, because like price is the same for the same number of V cores. So always remember to choose a V5, or maybe in a week we're gonna have V6, V7, whatever. So always remember like to choose the newest generation of the compute. And it does happen that people, like for instance, showing me the benchmark results that are not really good, and then I see what kind of what kind of compute they've been using, and yeah, it was for instance V3, right? So yeah, you can expect this kind of results when you choose the old generation. And the same with the storage. So recently we announced public preview of the SSD V2. And before we just had premium SSD. So this is what we call V1, right? Obviously. And like I believe like these numbers are pretty clear, right? If it comes to the throughput, it's 4.5 times higher than the V1 version. The same when it comes to the latency, which is like 45% less than in the V1. So if your region like has this option, because we have not deployed SSD V2 in all the regions yet, definitely go for the SSD V2. Okay, and now going to the software, like from the hardware to the software. So Postgres has really stable release cycle. Each year we've got a new major version. So major version, it's like 10, 11, 12, 13, 14. We used to have like 9.0, 9.1, but luckily starting from 10, like the major version changed to be just 10, 11, 12, like to be just less confusing. And you've got really cool feature matrix on the Postgres.org page. I just chosen the performance because this is the talk about performance, right? But you've got like a bunch of different features per version. And with each major version, really, you've got a lot of improvements when it comes to performance. And some of the major versions are even like mainly focused on the performance. So you probably will not see other kind of features like for HA, for walls, for whatever else. For security, you'll probably see that. But yeah, we've got some versions that are focused only on the performance. So definitely, if you are still running 12 or 13, yes, go to the newest one, which is 16 now, and you've got major version upgrade feature, which is just one click, and you go to the newest version of Postgres. Also, a bit software-wise, because on Azure we used to have our first managed Postgres service, which was called single server. Currently, single server is on his way to be deprecated. But we've got something instead. We've got flexible server that is much better performance-wise, feature-wise, and this is the service that we are investing to. This is the service that we are improving all the time, and we are working on. Nobody's working anymore on single server. The only mode we've got for single server is the maintenance mode. So really move to the flexible server if you are still in the single server. For instance, like what is maybe my favorite feature like of the flexible server is built-in connection pooler. We've got built-in PG Bouncer on the same VM where you've got your database server. And it's just, you are just enabling PG Bouncer and you can just start using it. So it's really it's really much more easier than on-prem when you need to like download the binary, you need to install, you need to configure. Like it's just one click and you've got the PG bouncer out of the box. And stop start. So if you're not using the server, you can just stop it and just start when you will start to use that. So it's new version of the our service. Okay, Dilip.
Hello, everyone. Good morning. My name is Dilip Ramachandran. I'm Senior Director of Marketing at AMD, and I'm part of the server business unit. Today, what I'd like to share with you is some of the performance analysis that we ran through a third-party company on flexible server versus single server. So we'll go into more details in the subsequent slides. And just want to ask the audience here before we get started, how many of you are using single server today or flexible server? Anybody? Okay, so flexible server, few people are doing that. Okay, excellent. So I think one of the things that you'll see here is that there's an AMD-based option for these things. So you may want to look at some of those as you evaluate your your workload. So just a quick overview of the different offerings on Azure that are AMD-based. On the left-hand side, you will see general-purpose instances, the E and D, and as well as the V5s that are in production, and V6 that are coming very soon. And then you can also see, the confidential computing instances at the bottom. Those are basically security encryption virtualization enabled on AMD. So these are for highly confidential workloads that you want to run on the cloud. Then you have HPC instances as well that are AMD-based. You have visualization and accelerated instances. For example, GPU-based instances based on AMD GPUs. These are some of those. And the last one is storage optimized for NVMe-based instances. So you have that. So let's get into the performance. Again, we used a third party to run this benchmark. The report link is included in the presentation in the last slide, so you can go and look at it in more detail. And we ran, just to give you an idea, the benchmark that the third party ran was a T-proxy, similar to TPCC type benchmark. And it was run on DADS instance, so the D instance and 16 VMs. So we ran it on Flex and Single. So specifically, the instance that we ran it on the left-hand side, that's AMD based. You can see here the flexible server, the CPU utilization is much greater, which is really important because you want to have your CPU utilization fully, probably close to 80%. But really, this is where we are running it is around 50%. And the single server is much lower. So you're utilizing the CPU, you're actually leveraging the performance. It's based on a third generation AMD EPYC processor. So EPYC is our product code name for our server CPUs. And in this case, we use a 64-core CPU here. And, it's essentially features 64 cores and a large L3 cache as well. And the clock speed is about 3.5 gigahertz. So this is the hardware that it ran on. And we're comparing against a single server, which is not AMD-based. Obviously, it's Intel-based. It's an older instance. And we will look at a couple of performance metrics, number of operations per minute, as well as IOPS. And then we're also looking at performance per dollar, which is very critical, in the cloud. Obviously, you want to make sure that you take the best optimized performance per dollar instance that is available. So looking at the performance, on the left-hand side is the database performance. And you can see here number of operations per minute. The flexible server based on AMD EPYC is about 4.7x higher than a single server. And then the next one is the database throughput, which is the IOPS. Again, this is an old TP type workload. So you're basically getting number of transactions and IOPS per minute. And in this case, the IOPS is about 2.86 times faster than the single server. So you can say, yeah, this is great. I mean, 3x, 4x better performance. You would all like it, right? But you want to make sure you're getting that performance at a reasonable cost or something that's better, actually, from a performance per dollar standpoint, so that you're not spending all your money on that. So how does it, the next slide really talks about how does it compare from a performance per dollar standpoint. And that's the next slide, which is essentially price performance. And if you look at it, the AMD-based flexible server is actually 3.8x, 3.9x better performance per dollar compared to single server. So not only you get higher performance, but also better performance per dollar with the flexible server. So that concludes my talk. I'm going to pass it back to Alicia and let her continue with her presentation. Thank you so much.
You are fast. Okay, thank you. So yeah, you saw that. Sven, okay. You saw that flexible server is faster, and yes, a lot of our customers do see like huge improvement when migrating from single server to Flex, because also what we did, like we made sure like the architecture of the Flex is much more aligned with Postgres, with just Postgres, with how Postgres was designed from the very beginning. And if you are still on the single and you want to migrate to Flex, we've got the migration service. We've got both offline and online mode. So this is something that you can use directly from the portal and migrate your single server to the flexible server. And it's really worth it. Okay, so probably one of my favorite topics, which is, yeah?
Sorry. Quick question. Are the migration assistants available from GCP as well?
Let's see. I see AWS and EC2. So I'm happy like to take this question to the migration team and ask if that's also, it's GCP is also supported. But basically whatever is like, Postgres, it should be supported. But I'm not 100%. I can ask my migration colleagues that doing migration. Okay, and the connections. Yeah, it's really my favorite topic because there's a lot of customers that come and say like, okay, my CPU went up to 100%, right? And of course, like there might be a lot of reasons of that, right? There might be some queries, there might be connections, there might be really a lot. But one of the most common is simply the connections. And if you read about Postgres, I don't know why this myth, like kind of where it comes from, because most of people like do associate connection with memory. So the people usually say, okay, you've got a lot of connections, so your memory usage will be high because for each connection, you've got the specific work mem amount. No, you don't. I really don't know where it comes from. Like, work mem is not used for every and each connection. If you are doing select one, you will not use any work mem. You will just use like very tiny, like part of the connection and like of the memory, sorry, and it will be hardly visible like on your server, which are not Amigas anymore, right? It are much bigger. They've got much bigger RAM. What you will see is the CPU problem, especially when you're just doing like if you're establishing a lot of connections at once, then your CPU will go really, really up. So yeah, so just please remember, like if you've got a lot of connections, mostly it's not memory problem, it's the CPU problem. It's because like how Postgres is processing how Postgres architecture works, right? Like you've got like separate process per each connection. So that's why you see like this huge CPU spikes. And although we in the flexible server, like we do have these limits, which are pretty high, like for most of the instances, you can go up to 5,000 instances. And unfortunately, like this is super often I hear that, okay, we are expecting much bigger load in a week, so we are going to increase the number of connection. There is nothing, there is nothing worse that you can do. Yeah, I see the question. I don't hear you.
Is the microphone live? It's on? Okay. So regarding the CPU utilization, Is there a way to tell if that's the process is doing something or scheduling overhead of that many processes being swapped in and out of the CPU core? Can I tell the difference?
Yeah, unfortunately, we don't have this kind of metrics in Azure. You've got like, at least for flexible server, you've got just very simple like metrics like CPU utilization, memory utilization. I know what you mean, because on-prem, if you are just having like Postgres on just normal, machine, Linux machine, you're able like to monitor almost everything, right? Unfortunately, we don't provide this kind of information like you would have like in the CPU info or something like similar tools. So no, you will see just that, but we've got something instead. We've got troubleshooting workbooks. We've got query performance insights. So you've got alternative ways of seeing the same, but not the same as you've been using on Linux. So yeah, so this is super tempting, right? Like, so I'm gonna have more load, so I'm gonna increase max connection. And it's really like the worst you can do for your application. In Postgres, and I really love this wiki page, and especially this that I'm quoting like very, very often. So let's read it out loud. PG will usually complete the same 10,000 transactions faster by doing them 5, 10, or 20 at a time than by doing them 500 at a time. Determining exactly how many should be done at once varies by workload, obviously, and requires tuning. So yeah, we had I had multiple example of that recently. Even my customer said, okay, there is a change in the application. We're gonna have twice that much connections. So let's try to increase this number. And when at the moment when they increase the number of connections, the latency from the application has grown 4 times. Really. And when they went down, latency was much, much smaller. This is, I know it's super counterintuitive, I know, at first, but then when you're doing benchmarking, when you're doing any test, you will see that on your own eyes. And that's why we've got PG Bouncer, which is built in the service. As you see, this is on the exact same VM as the Postgres is hosted, and you are just enable that. And also another important point, it's not like you want to have 5,000 connections, so you're gonna open 5,000 connections from PG Bouncer to Flex, because you will not gain any performance this way. You need to think about this as a funnel. Okay, so you can have 5,000, for instance, in here, so between the application and the PG Bouncer, but between the PG Bouncer and the Flex, you need to keep the connection count really, really low. And what do I mean by low? You've got some, for instance, the most common one is the number of CPUs times 5. Because yes, we need CPU for the connection, okay? CPU, not memory. And yes, you've got, for instance, 8 CPUs, then 8 times 5, I believe 40, right? So we start at 40, and you can go up and down, and the best way to measure it just measure the latency from the app, okay? From your own app. And then, this is just before after slide. So I know it's very small. So so blue one is the CPU utilization, and the red one is active connection count. So as you see, the transaction count was at the same level, but we are able to go down with the CPU utilization just by limiting the number of the connections. And that would be it. Just in summary, make sure you always place your application and DB in the same AZ. If this is not possible, at least in the same region. You maybe want to set up some kind of alert on the wait event, which is client read and state idling transaction. So you will know, like, if your application will do something weird, or some other application would like to connect from another region. The second would be always use the newest version of hardware we do offer. So both compute and the storage. So SSD v2 for sure, and for sure v5, and for sure flexible server, not the single server. And at the end, remember about the connections between, because like connections are a really huge problem in the Postgres setups, and they're totally counterintuitive. So always remember to have like the connection count like that you've got on the database, like really low, and adjust that to the number of CPUs you've got on your Flex server. And yes, I will ping the slide. So I've got a bunch of links also to this cool website with regions, the interactive ones. So if you would like to see, yeah. Thank you. Any questions? No questions. Okay. So thank you everyone, and have a nice rest of the day.